you're interested. Thank you for your passion to attend this webinar. We really appreciate it. For your information, webinar is one of the GLC Network's regular event every Thursday night with any variation topics. For about next 1 hour, we will share and discuss about the topic for webinar tonight is building an outdoor wireless network with Mikrotik. So prepare yourself and stay focused on that. During that webinar, if you have any question, you may drop the message in the chat box or just unmute yourself and ask question directly. And by the end of the webinar, we hope you will get something positive, something benefit, something useful to improve your skill and knowledge. So let me introduce you to the speaker tonight, Mas Ahmad Mardiansyah. He is a founder of GLC Networks. He is also trainer, mentor, and consultant for IT and ISP. Also experienced in domestic and overseas projects. So are you ready for your slide, Mas Ahmad?
Yeah, sure. No worries.
Okay, let's get started. The floor is yours. Thank you and enjoy the webinar, guys.
Okay, thank you, admin. So, okay, my name is Ahmad, and then I'll be talking about a topic here, building outdoor wireless network with Mikrotik. Okay, because why wireless? Because everyone loves wireless. Yes, why? Because it's easier. No need to, I mean, it's cheaper, easier, and then sometimes lots of problems. Right. We'll be talking about the wireless things here. And then here's the outline for our webinar tonight. First, we'll be talking about the introduction, sorry. And then we do a review, prerequisite knowledge, and then talking about layered communication, talking about outdoor wireless, and then also, yeah, because here we assume that you're building your outdoor wireless using Mikrotik, okay? So that's why we'll be talking about the Mikrotik aspect of wireless, okay? Next, and then for you that is joined the webinar for the first time, we are GLC, Garden/Chakrawala. We are based in Bandung. Our areas are training and IT consulting. We're certified partner for Mikrotik, Ubiquiti, and Linux Foundations. We also have product named GLC Radius Manager. It's a software for managing user, a centralized user for organization. So that can be used for example, ISP, yeah, mostly for ISP, for managing their billings and then their user. Also for school, where you have lots of students, and then you want to make sure that only registered students that is able to log into the network. About myself, my name is Achmad. I'm based in Bandung. I'm Linux user, Mikrotik user, Ubiquiti user, also trainer. I'm teaching mostly related to networking, Linux system administration, and then programming. Some also have contributors for some websites, and also I'm a YouTuber. I mean, we are a YouTuber now, so please, what is it? The phrase that people often say often when they are in their channel, YouTube channel. Please subscribe, like, and share. And also, if you have LinkedIn, we can connect, right? Yeah, that's my LinkedIn. I would like to connect with you guys. About past experience, we do projects in overseas, in Congo, Malaysia, UK, in North Africa, mostly related to Mikrotik and networking, okay, integration as well. So yeah, that was our experience. About the webinar itself, we started in 2010, January 1st. We do a webinar every week, okay? but to upload on the YouTube, it depends on the situation. If we are busy, and then will be delayed. Okay. If you want to be a presenter, you're welcome. And the topics are, yeah, I mean, around system administration, Linux-based networking, either wired networking or wireless, and then programming. Okay, for yourself, I think, yeah, that's enough. Yeah, I can see, oh, okay, so already 40 participants here. Thank you very much for coming. And yeah, I really welcome you guys to the webinar. So hopefully you can get something from this webinar, which will be useful in your workplace. Right. Yeah, I have to say, in the beginning, I was talking about sorry, in the beginning, the title was building just wireless networks. And then when we think again, actually wireless network is a big topic, you know. And I think we can divide the topics, that broad topics, into two parts, building outdoor wireless networks and then indoor wireless network, because those networks are not similar, okay? Yeah. Also, when we talk about the outdoor wireless networks, actually there are several prerequisite knowledge that you need to understand. Okay, so that's why for some perspective, this presentation is not for beginner. Okay, so we assume you already understand these concepts, RF, radio frequency, about routing. Oh, okay. So I think I have to update this one. So actually, you have to understand things related to RF, okay, especially. So I need to update this slide. Sorry for that. Yeah. So this is for different topics. Sorry, I have to update that. Okay. So the thing is, before you learn about building about outdoor Mikrotik, outdoor wireless network, there are several terms or knowledge that you need to understand. All right. So what are those? Okay, let's find out next. Okay, so this is the prerequisite knowledge that you need to understand before you build a wireless network. First, you need to be aware that we are doing, when we do communication, we are doing communication in layered way. Okay, so we have layer 7, layer 6, layer 5, 4, 3, 2, 1. And then because we are doing here wireless, okay, so the concept of wired, sorry, layered network is every layer, yes, layer. Inside the layer itself, there are protocols, okay, the protocol for communication. So actually, when we learn about networking, actually we just learn about the protocol used for communication. And in terms of wireless, we have several standards here of protocols. Mostly for outdoor, we are using the protocol defined by IEEE 802.11. Okay, why it's 802? Because it was released in 1980s on February, okay, on month 2. We have other wireless specification for IEEE 82.15, 16, and others, okay. Those are for different technology. 15, I think, is for WiMAX, right? So this one is WiMAX, if I'm not mistaken. Okay, so I need to Google it. But here is what we usually call Wi-Fi. Okay, so 802.11. So those are the standards that we are talking about, that we discuss. So that means, because we are focusing on layer 1 and layer 2, okay. So we don't need a network, a session, application, whatever. So we're just focusing on here. So basically on one layer only. Okay, so it should be easier. Yeah. So it just looks like you're using a cable and then plug the cable and then off you go. You can do whatever you like. Okay. So here, this is the layered model. Okay. But for the encapsulation process, from top down here, oops, I cannot use pen. Oh, okay. So pen is working. So actually, the stack that the layer that we are talking about is this one on layer 2, which is frame. Okay, so this is the encapsulation process started from data, and then we have a segment or datagram if you are using UDP, and then on layer 3 we call it packets after adding a header of layer 3, which is the IP address. And then on layer 2 we will add another header. In this case, yeah, on the screen you can see it's Ethernet header. All right. So yeah, so this is the how the header looks like. Okay, in a more appropriate way. So one block here is 1 byte or 8 bits. Okay, so this is layer 7. This is your data on your WhatsApp, for example, or Facebook. And then here on what happened in layer 4. Okay, so this much. Okay, so actually when you send hello, the computer is not only send a hello, but the computer adds more and more information so that the message can arrive to the destination. So this is what happened when you use Ethernet. So Ethernet header is this long, okay? But if you're using wireless, okay, and then the header will be this long, okay? So it's longer than the Ethernet. Why? Because there are lots of controls on a layer 2, wireless layer 2, okay? So how it look like? Well, it looks like this, okay? So this is the data from upper layer, okay, from upper layer. And then this is address, okay. You have sequence control, address 1, address 2, address 3, duration, and then here you have frame control, and then you have a protocol version, to DS, from DS, or flag, so on and so forth, okay. So this is how the header looks like if you are using the layer 2 Wi-Fi, okay. So this is the header, and then this is the trailer, okay. This header, and then this is the trailer, and then this is the data from upper layer, okay. So it's longer compared to the Ethernet. Okay, next. Okay, so before we go, yeah, so this is the checklist that we need to understand, okay? So first you need to understand RF, because why this is important? Because many issues in wireless implementation, because the people, the admin do not understand properly what the RF is, okay? Yeah, they just know that, okay, I just click this button and then it should be able to connect. No, it's not, okay? Because you need to understand a basic fundamental principle of how wireless works, okay? How electromagnetic works. So first, you need to know about RF. RF means radio frequency, electromagnetic. So this is this knowledge is general knowledge, for electromagnetic wave, okay, EM wave. So what are the checklists? First, you need to understand the wave property. You have to understand what's the difference between frequency, amplitude, period, wavelength, phase, okay? And then you need to understand the difference between analog bandwidth and then the digital bandwidth. Analog bandwidth is using hertz, digital bandwidth is based on bit per second. And then, of course, this is very important, okay? You need to understand how modulation works, Okay, modulation, there are two types modulations, analog modulation and digital modulations. With digital modulation, we call it shift keying. We have frequency shift keying, amplitude shift keying, okay, phase shift keying, okay. And then for more modulation, we use QAM, quadrants amplitude modulation. And then based on those modulations, we can set up the MCS modulation and coding scheme. So we have MCS 0, MCS 1, 2, 3, up to whatever. Depends on the how many, they also, with MCS, they also include total number of antenna used for this modulation coding scheme. Okay, so those you need to understand. And then here, this is also important, Shannon-Hartley theorem. So this is talking about the channel capacity, and that what are the factors that contributes the channel capacity. Because we are using EM wave, EM means electromagnetic wave, so at least you need to understand several things about electricity and magnetism. So because this EM, this electromagnetic wave, why is it called electromagnetic wave? Because it generates from electricity and magnetism principles, right? So after we understand, and then for wireless communication, we also have wave. Wave has its own properties. When we use wireless as communications, there will be another properties like channel, okay, usually based on frequency, and then channel width from this frequency to that frequency, right? And then we have a signal strength. Usually it's depicted by dBm, okay? And then we have a coverage. We need to understand what's the difference between simplex and duplex, full duplex and half duplex, all right? We need to understand about the standard organizations, ITUR, US FCC, IEEE, ISO, Postel. This is for Indonesian, Post and Telecommunication. We need to understand the regulations, okay, because you cannot use any frequency you like, man, okay. Here in Indonesia, we have a monitoring body, yeah, which always scans the frequency. If you are using illegal frequency, they will come to your tower and then take you down, okay? And then you have to pay an amount of money. You need to understand about the regulations, frequency, channel width, IR, okay, intentional radiator, EIRP, and outdoor or indoor usage. Also, you need to understand about RF behavior. What is the difference between propagations, absorptions, reflections, scattering, refraction, whatever. And then free space, path loss, okay. And then the phenomena of multipath and then gain, okay. This is also important, okay, units of power. You need to understand the difference between watt, dBm, dB, decibel, and dBi, decibel isotropic. Okay, watt is watt. Okay, for it's a unit for power, but watt and dBm is an absolute. Watt and dBm is an absolute unit. Okay, so it's always compared to a specific amount of already static. For example, dBm is the power that is always compared to 1 milliwatt. Okay, watt is watt. Okay, while dB and dBi is depends on it's a relative comparison between two sources. Okay. And then you need to understand the RF components, like what is TX, RX, okay, IR, and then EIRP, intentional radiator. I forgot the. I'm not good at with the acronym. Okay. Also, we need to understand about the link budget. Okay. Yeah, with the dBm, of course, and then we need to understand the noise, the concept of noise. Between the noise floor and then the signal. Okay, so you have to make sure that your signal is much higher than the noise. And then there is a parameter called SNR for that, which depict how high is your signal compared to the noise floor on that particular frequency, because every frequency has a different noise floor. Okay, why? Because perhaps in several frequency, people are already using those frequency for another purpose, for example. Here we also have a CCQ, okay, how CCQ works, client connection quality, and then you need to understand the concept of retransmission on layer 2. So remember, we have a layer 4, right? And in the layer 4, you have TCP, correct? And then with this TCP, we have a concept of retransmissions, and then with the mechanism of acknowledgements, and then a sequence and an acknowledgement. On layer 2, there is a retransmission as well. Okay, so you need to be aware of that. Also, you need to know about the RX sensitivity. Okay, so when you buy an equipment, there is a data sheet. It's a sheet, okay? It's a data sheet. You call it data sheet, okay? SHEET sheet, okay? Which explain the technical details of the products. And one of the parameter is called RX sensitivity. So when you are approached by a sales guy, okay, most likely they don't talk about technical, and you guys are technical. So one parameter that you need to check on that equipment is RX sensitivity. Okay, so because the data sheet is the most truth source of information that you can rely on, not from the sales guy. Okay, sales is just for sale, and they just want to making money. But after you buy the equipment, it is you who is dealing with the equipment. And then you need to know about the TX power and then data rate policy. Okay. Sorry. Yeah, I need to talk about this thing. Okay, because yeah, well, actually, if you already know all of this, and then um, um, using wireless communication should not be hard, okay, because you already understand the fundamentals. Okay, next checklist is related to RF signal and antenna. Okay, antenna plays important role because so this is the unit. Okay, and then after the unit, and then there will be an antenna here. Okay, and then it connects to the, okay, this is TX, and this is the RX. Okay, so this is the antenna. Okay, and then here's the unit. Okay, so antenna here plays very important role for wireless communication, because they are the one who is doing the uh, increase the signal. Okay, so each antenna must have azimuth and elevation chart, uh, as we know as a radiation pattern. Okay, so similar to like when people are using radar, actually they are sending electromagnetic wave and then expect some reflection from an object, either it's from aircraft or from uh, from for example, from what is it, from clouds. Okay, so there is a, if you see radar. Okay, so when we talk about radar, radar is not only detecting aircraft, detecting the metal objects that is flying on the sky. No, no, it's not like that. But there is a weather radar. Uh, weather weather radar. Okay, so it's checking the clouds. Okay, are we going to have clouds in the tomorrow, or what will be the um, um, weather for the next 24 hours, for example. Okay, so that's yeah, that's device we can use for many purpose, not only for communication, but also detecting objects. Next is antenna itself. Lots of things. We need to understand the antenna based on directionality. So we have omni antenna and then directionality, directional antenna. So the signal is much more focused on a certain direction. Here we have types of antenna like omni antenna, patch antenna, like the one in your mobile phone. You have a Yagi antenna, sectoral antenna, grid antenna, solid disk antenna, and then inside the antenna, there will be a data sheet also that explains the gain of antenna and then the polarization of the antenna. Also, you need to understand the beam forming, the Fresnel zone, the antenna diversity, because previously, before 2010, yeah, I think, yeah, that's when I learned the, yeah, I started wireless in 2010, yeah, and then at that time the MIMO concept was relatively new, but some of the vendors already made them. So the idea is people are using multiple antenna to transmit and receive. So you need to know the difference between CISO. CISO means single in, single out. Okay. MIMO means multiple input, multiple output. Multiple input means several antenna to receive signal, and then multiple output for is multiple antenna for sending the signal. And then the use of MIMO is can greatly introduce, can greatly what is it? Increase the data rate. Okay, so which is good. Okay, increase the data rate. Okay, so if you want to buy a access point, make sure that it supports MIMO. Okay, because that one can increase the speed as well. Also, when we talk about the wireless stuff, usually we talk about the AP and then station, right? So AP means access point, and then station connected to the sorry, sorry, access point. Okay, so make sure this is MIMO. Mostly IP are now MIMO, and then on the station, make sure it's also support MIMO. Cheap device, okay, cheaper device, they don't support MIMO. Usually they just still use CISO. Okay. Expensive device like Apple, they are using MIMO on their products. Also, you need to know about the antenna accessories like cables, connectors, PoE, splitter, amplifier, attenuation, lightning, arrestor, grounding, and so on and so forth. All right. Look, guys, if you have questions, and then just type here. Okay. Also, you need to understand about the standards. Okay, so we assume you already know 802.11 standards. The standard defines the channel width, either it's 20 or 40 or maybe 80. Okay. The frequency band usually is 2 gigahertz. Okay, or 5 gigahertz. Okay, or maybe 60 gigahertz, and so on and so forth. Okay, so this bands is free to use. If you use other than this band, and then you are not allowed to do so because the frequencies is already allocated for other purpose. Okay. Other principle from IEEE is you need to understand the difference between CSMA CD and CSMA CA. Okay, CSMA CD is used for Ethernet, for wired, and CSMA CA is for wireless. Okay, why do we need CSMA CA? CSMA means carrier sense multiple access. Okay, so it means that there is a media. Okay, so every device that connects to the media uh, will uh, will check the sense, will sensing the traffic on that media. Okay, and then if we use CD, okay, and then there will be a collision detection. But on wireless, we don't want to have collision because we cannot detect the collision. That's why we need to avoid the collision, because unlike if we are using CD, okay, if there is a collisions, and then we can easily detect the collision, because for example, when you are sending here is 5 volts, and then this is customer 1, this is customer 2, client 1, client 2, client 3, and then it's sending 5 volts at the same time. So when they are sending at the same time, the concentrator, for example, hub, receive them at the same time, and then there will be a 10 volts. Okay. Oh, okay. So if it is 10 volts, and then oh, okay, there is a collisions, and then everybody must stop, and then waiting for random periods so that you can send it back. With wired connection, it's very easy to detect the collision, but for wireless, no, you cannot. How can you detect the collisions? Okay, so that's why the principle on wireless is not CSMA-CD, but CSMA-CA. Okay, and after that, we'll be talking about the topology, either distributed system (DS) or wireless distributed system, or WDS. So that DS is like you have AP, another AP, and then another AP here, and then all of them will be connected to via cables. Okay, so that's called DS. But for WDS, it's different. So you have AP, AP, and then AP. Okay, so this AP will connect to each other by themselves. So there is no, they are not relying on uh, uh, there is no underlying infrastructure to connect them. So they just connect by themselves. Okay, so that's the difference between DS and WDS. All right. Okay, so that was the 802.11 standards. And then a wireless on Mikrotik. So we assume you already know these features on Mikrotik. Okay, so on hardware, so if you want to buy a Mikrotik products, you can buy your own wireless card. So there are products, Mikrotik products that has wireless card separately. So you can like a plug and play if you don't like the card, or you can upgrade. There is a slot, and then on that slot you put the wireless card, and then after that you connect them to the antenna. So it's a separate, it's a modular system. So you buy, well, for that one you have to buy several equipments. Okay, so you have to buy the unit itself. Okay, and then you have to buy wireless card. You have to buy cable. Okay, and then connect to here, and then you have to buy antenna. Yeah, or you can buy built-in. So all of them already combined into one product. Okay. So from the software features, we assume you already know the registration table, scan tools, snooping, frequency usage. There is a tool for checking the frequency, which frequency that is used for communication. Your Mikrotik can have ability to scan the particular frequency. Okay. Also, you can use spectral scan, and then here's, this is also good. Yeah, spectrum analyzer. Okay. Here you can use the diode to use the spectrum analyzer. And then there is a alignment features to align several. If you want to do a point-to-point, usually for point-to-point PTP, okay. There is a sniffer, regulatory domain, data rate policy, okay. You know, on Mikrotik there are lots of settings, okay, for wireless. So that makes people sometimes overwhelmed. I mean, especially for those who are new to the product. Sorry for that. You need to understand the multiple change. This is for MIMO. Okay, you need to understand about the access list and connect list. Okay, access list is for incoming, for inbound, connect list for outbound. Okay, also we assume you already know how to configure the wireless security like WPE, WPA, WPA2, and then frame protection. This is a feature for Mikrotik. To avoid, for example, if you have an outdoor wireless and then somebody that clones the MAC address that can connect to you. Okay, so with with the frame protection, even though they can clone your MAC address, they cannot connect to you. TX data rate, and then some Mikrotik proprietary wireless protocol like Nstream or NV2. All right. Oh, next about the outdoor wireless. Okay, so outdoor wireless, when we talk about outdoor wireless, so it's a wireless network that is located in outdoor environment, of course, as the name suggests. Yeah, it's very simple. So outdoor wireless should be placed in outdoor, okay, outdoor environment. Usually it's PTP or PTMP. So this is the picture. Okay, so this is one of our tasks. So we have a task to connect. So there is an office on top of a. I cannot say this is. It's up to you. This is a mountain or just a hill. Maybe on top of the mountain, a small mountain, maybe perhaps. So this is there is an office here. Okay, and then we need to connect. We need to feed the office with the internet connection, and then we feed them from the antenna here. So from here we connect to that, and then the distance is about 8 kilometers. Okay, so here we are, like this. So here, and then also this one here. Okay, and then this was me configuring the device. So this is just one example of how you connect the wireless. Okay, so yeah. So yeah, this is how the outdoor wireless looks like. Okay. So after you successfully connect, you do a bandwidth test, and then off you go. Some equipments, components. Okay, so when you build a wireless components, okay, first is the radio equipment. It's the main unit. Here it is. Okay. Or this one. No, this is just antenna. Okay, so this is the built-in. Okay, the built-in. Or maybe this one. Okay, so the small things here is the radio. Okay, and then after that, what you usually need for outdoor is the antenna. The antenna plays important role. Okay, so this is the antenna. Okay, here's the antenna, and this is also antenna. Okay, this antenna is called sectoral antenna. Of course, usually for outdoor, in order to make a clear path for communications, usually you put the equipment at the tower. Okay, so this is not tower. Okay, So this is not tower. This is just for testing. Testing the equipment. We put it on the tree. Okay, just for testing the equipment. Okay, but usually you have a pole and then you mount your equipment there. And then usually the equipments are mounted on the tower. Of course, you need to have a safety equipments like this one and then harness. Okay, of course, because they are putting on top of a tower, there will be, you need to think about the a power source, okay? And most likely for outdoor wireless equipment, uh, you will need the PoE. And then for that PoE, you need a very good cable, okay? Why good cable? Because it has to have supply power to the equipment. If the quality is bad, and then for 5 meters, there is no, there is no. I mean, this is I'm talking based on the my past experience. Okay, if you have a bad cables, a cheaper one, the PoE cannot go more than 5 meters, for example. Okay, the good cables must be created from copper. Okay, copper. But the cheaper one, maybe they are combined between copper and iron. Well, this is cheaper. Iron is cheaper, but cannot go far. Okay, and then by the time goes, and then the quality for the electrical signal will be decreased, and then you have to replace the cables. Okay, so whether if you do, um, I mean, if you use a good cable from beginning, okay, it's a long-term investment. If the cable is good, you can still reuse it for other sites. Okay. Next is Mikrotik for outdoor wireless. Well, if you take a look at the Mikrotik website here, so this is Mikrotik website, and then you can see product categories, right? So you have a wireless system and wireless for Soho. So yeah, Mikrotik categorize their wireless products into indoor and outdoor. Usually for indoor, they are combined with the routers. Okay, with the for Soho, small office, home office. Okay, so they put it that way. And then for outdoor, they put it here. Okay, so you can buy a unit only, just the unit. Okay, so you buy the antenna separately. Okay, or you can buy product with built-in antenna, for example, this one SXT. Okay, other tools is for this one, it's like product metrics. Okay, so you compare between one product to the other products. Okay, next is the other tools is the product guide. So this is very useful. Okay, so I want to build a wireless link. Okay, and then which product should I choose? Well, you can just come to the uh, tools here. Okay, so it's a selection guide for point-to-point links. So you select the frequency, and then here are the uh, here are the uh, the products. Okay, so if cube connects to the other cubes, and then uh, what will be the maximum data rate you can achieve. Okay? But again, this assume that the data rate is done in very ideal way. Yeah, they can be you can do like you can do point-to-point calculation like this. Okay, but you have to understand that this is ideal way. What do you mean by ideal? Ideal means there is no noise, no other things. Okay, uh, I mean, you're just focusing on the two. You're just focusing on the two sides for your testing. Okay, so actually the page here is quite long. If you scroll down, and there will be how much kilometer it can achieve. Okay, so as you can see, if you are using again antenna plays important role here. For example, Dynadisk is using a solid disk antenna. Okay, and then that antenna is very good for receiving and then transmitting a signal. So that's why here it can go farther compared to other products. All right. Oh, okay. So finish. Okay, I don't have a live practice here because this is wireless. Okay. Any questions so far? Okay, somebody is asking about my email. Well, you can see my email in the first slide. That's my email. Okay, hopefully you can take it note. Okay, any questions so far? Again, when we talk about wireless, we assume you already know, again, these prerequisite things, okay? Okay, you need to understand the, yeah, I mean, this checklist, okay? You need to understand the radio frequency, the RF signal, and then the antenna, okay? Understand the standards, understand the features, okay? And so on and so forth. Any questions so far? Looks like I'm very silent. Okay, any questions? No? Okay. So perhaps I can do some checking on Mikrotik
Hello.
website here. You can, oh, okay, so yeah, you
Hello.
want to say something? Yes?
Yes, I want to ask a question. So, we're using Mikrotik for our ISP company. So the highest link we have is around 10 kilometers. So, we wanted to make a link for 15 kilometers. So my question is, what is the best antenna and you need to use for that scenario?
Yeah, it's very common questions. And then with these tools, you can, hopefully you can, it can answer the question. So I already share my screen here. Okay, so you can click, there is a selection guide for point-to-point links. Okay, so it's up to you. You can select your frequency, 5 gigahertz, for example. And then you can see the distance here at the below. Okay, so distance here from 0 to 200. Well, for you, 15 kilometers is this one. Okay. So this is 15. So what you need is 15 kilometers, right? So around this one. So we can scroll up. And then, well, you can, if you want, you can use QRT, yeah. QRT5 or Dynadisk or XL LHG, okay, or Dynadisk, okay. Yeah, you have lots of options here. Okay, so hopefully that answered questions. So actually that kind of question is very common. So yeah, hopefully that answered questions. Okay, another
So
question. Is it
what
possible to propagate wireless signal in area with 10 square acre? 10 square acre. So 10 square acre means what? 10 millimeter square, 10 meters square. Yeah, so guys, when you see, so when you see here, so the distance here is from 0 to 200. Actually, not even 200. I cannot see links here that can reach up to 200. But this is the guide where you can use to connect your equipment. So as you can see here, MCS7 is the highest modulation. So if you want to use, you want to achieve as high as possible using this. So I really recommend the point to point that can give you a red number here. Okay, for the MCS7. So for example, this product QRT5AC. Right, so hopefully that answered the question. So yeah, about the question here, propagates wireless signal in area about 10 square acre. Acre means meters, right? So 10 meters square, right? So 10 meters square means like this. This is 10 meters, and this is 10 meters, right? Well, for this one, we can use indoor or omni, okay, which radiates signals to, yeah, to omnidirectional. So omni means to, yeah, to all direction, okay, to all direction. So yes, it's possible. Yeah, so 10 meters square. Next question. This could be used in the phone with 1 bar signal system on the phone. Okay. So for that one, I suggest you can use LTE products. So for example, we use this product as well. So if you see here, so Lte Modem. Yeah, for example, this one, okay. So we have project in Indonesia where we are located in remote area. So this is the GSM tower, okay. Okay, so they have antenna like this, and then this is your site, okay. So it's very far away. And then your phone, if you use your phone signal is very bad. So here we put a pole, just a small pole, like a small tower, and we mount here on this, and then they will connect to this, and then the signal is good. Okay, so it is designed to connect to the GSM signal. So as you can see, this product is to connect to the GSM tower. Okay, so this is not to provide connectivity local. So they don't design. They are not designed to connect to the to provide the Wi-Fi access. So one product here to connect to the GSM, and then another product here to give signal to the Wi-Fi. Okay, so 10 by 10 means, okay, yeah. So yeah, sorry, this was a miscalculation. So 100, yeah. So if you have a 10 meters here and then 10 meters here, total area is 100 meters square. Yes, correct. Okay. So if it is 10 meters square, so it's like 5 by 2, 5 by 2. I mean, this is very small area. You can pick any equipment you like. Okay. Again, same question, right? I'm not kidding. So what is the maximum? Well, guys, you can use this tool, okay? A product selection from the Mikrotik. So if you are, I mean, this question is always coming again and again to Mikrotik. So that's why they built they built a page here for you, so that you can check your own. Okay. So if you see QRT5AC, so as you can see here, see, so maximum is 32 kilometer at MCS7, 155 kilometer at MCS0. Next, what is it here? Yeah, so 155 kilometer at MCS0, 180 kilometers at 6 Mbps. So it's very, very small. It's not recommended here. So at 52 kilometer is 64 megabit per second. So 32 kilometer at MCS7. Okay, so hopefully that answered the questions. Okay. So if you check what is MCS7 data rate, and then there is a software here, MCS7 data rate. So usually there is a website called MCS Index. Okay. MCS7 index data rate. Usually I don't remember. Here, mcsindex.com. Okay, you can check. Okay, you can see here. See, this is MCS index, MCS7. Okay. Okay, so it's using 64 QAM is the coding. So if you are using a 20 megahertz channel, and then this is the megabit per second Mbps that you will get. Okay, so if you increase the total channel width, and then this is the bandwidth you will get. Okay. So this is assumed you are using special stream of one. So it means that you are using one antenna. If you are using more than one antenna, and then yeah, here's the calculation. Okay. So as you can see, the more antenna you have, there will be an increase of data rate. Okay. So this is the OFDM prior 11AX. So there is a new Wi-Fi protocols. So previously we know 802.11b, 11g, 11n, 11ac, and then in the future, in the near future, I think there will be 11ax. Okay, so which is the multiple mu MIMO, yeah, and then here's the calculation of them. Okay, so this is mu. Mu means multiple MIMO. Okay, anything else? So hopefully that answered the questions. Again, when we talk about the wireless, I really assume you already have the prerequisite knowledge for understanding the how wireless works. Anything else? No? Finish? No more questions?
I have a question. What's the best antenna to use with the Mikrotik net metal?
Well, you can see here, Mikrotik also sell antenna. So if you are looking for antenna, yeah, it depends on the purpose. Okay. So antenna like this usually is for point to multi-point. Okay. Antenna like this, yeah, like this. Usually is for point to multi-point, but for this one and here, that one is for point to point. See, point to point antenna. So you can see the data spec of the antenna. So you can click here. Oh, I think with this kind of questions, I think I can be considered as a Mikrotik sales engineer, right? Selling things to you guys, people. Mikrotik should reward me something here as their sales guy.
Yeah, I think
Okay.
this.
So yeah, this is the specifications. Okay. I cannot see the gain, so it should be written somewhere. Oh, sorry. So this is the radom. Radom means the cover. Okay. So I really suggest you to use the to use the antenna with the solid parabolic dish like this. Okay. So for example, this one here, it has a beam width. Okay. Front to back ratio, impedance. Yeah, as you can see, there is a spec here for example, yeah, 30 here means 30
Yeah, because
dB. Yeah.
the problem that we are having now is we have a point-to-point link with two LAG5AC devices, so they're both XLs. So the problem that we are having now is at first it was okay when our data rate was below 100 Mbps. Now it's more than 100 Mbps, and clients are increasing at the site that we are taking the link to. So the problem is we want to have a device that has a higher data rate. So that's why you want to use a net metal.
Oh, okay. So so currently, sorry, I don't understand. So currently you're already using LSG, and then it can go up to 100 Mbps, but sometimes it can go below 100.
No, it can go to 100 Mbps, but the problem is at 100 Mbps the latency is very bad.
Ah, okay, yeah. Okay, I understand.
Yeah,
Yeah,
it means you are already reaching the capacity of the device, so it's becoming bad.
yeah. For that one, so LSG. Yeah, well, for that one, yeah, for example, if you already reach 100 Mbps, that is already good. Yeah, it means that the quality of the link usually is much better. You can use higher modulation. So if you want to replace them, well, you can use product um, with the product um, that has more than one what is it, one antennas, multiple antenna, so that it can stream more data to the to the uh, to the equipment. Okay, to the other units located in the different site. Is it point to point or point to multi-point?
So I should use Ment 30 with the net metal.
Yeah, for net metal you can. Net metal has what is it? Where is it? Net metal. So we have a wireless system here,
Okay,
and
so
then
one
because
last little question is, can we use net metal with other antennas from other vendors?
Yes, yes, it's possible. Yes. Yeah, so this is net metal 5. As you can see, this is HHP. HP means high power, so that it can generate more power compared to the other type. Okay. So this is net metal, and then as you can see, yeah. So this is the wireless specifications, and then yeah, for the data rate, yes, you can. You can use antenna from other vendors. Yes, it's possible. Sometimes we also use the unit itself, not only coming from the Mikrotik, but from other vendors. Okay, but for antenna, you can use antenna from RF elements. Okay, so yeah, this is one example of antenna. They have antenna for a point-to-point and then point-to-multipoint. Okay, so perhaps this can be one brand that could be your consideration. Others are ALG.com.
Yes, because we want to we are based in a city, but at some village next to the city that our ISP is at, the people, the community at the city, they're having problems with internet. So we've been giving them internet with the SXT LTER. So that thing now it's bad because the LTE tower is now having capacity problems. So we want to have a point to point going to the village. So you want a long distance link with maybe micro another
yeah. If you want to achieve, I mean, based on my experience in some wireless, so if you want to achieve the capacity, and then usually you are using a point to point. A point to multi-point is usually for a short distance, and then I mean, if there are many players that is using the same frequency as well, and then you'll be in trouble. I mean, you know, the problem with the wireless ISP now is running out of a frequency, because I'm running a wireless ISP. Okay, I'm using 5 gigahertz because that is the free license from the government. And then there is another company also doing the wireless ISP, and then using the 5 gigahertz, same band like me. Okay, and then their tower is quite similar. I mean, located near to my tower, and then there will be noise, and then a signal is not good, and then bad signal happens, and then people are complaining. So that's I mean, that's what happened if you run a wireless ISP. Other than that, wireless ISP is cheaper to be implemented, but for maintenance, it's a little bit headache. That's what I can say. But again,
what we do.
Yes.
Okay, what we do is on the backhaul, right? On the backhaul we have point to point going to every site, because our PPOE concentrator is right at the ISP building. What we do is we have an MPLS network running with OSPF and BGP. So we send a VPLS tunnel to every tower that we have, every site that we have. Then the clients, they connect with PPOE.
Yeah. So at the CPE, they are dialing with the PPPoE to the central concentrator at the main office, correct?
Yes.
And then to go there, and then you are setting up MPLS, and then create a VPLS tunnel from the edge router to the central router. Yeah. That can be done as well. Yes, true. Okay, I think hopefully that answer the questions. Where are you from, by the way? Mr. what was the Tutu Makala?
I'm from Botswana, Tito Makala. Yeah, I missed the other item webinar that you guys had because I was pretty busy, but I wanted to attend it. It was for, is it BGP routing? I wanted to attend that because that was a big topic.
Oh, okay. Yeah, perhaps we can have a schedule in the future talking about BGP in different aspects, because BGP itself is a quite big
I'd
topic.
love that. Yes, I'd
Yeah.
love that because we want to enter in the internet exchange at Terraco at South Africa. So we want to be a part of the internet exchange. So that will be very helpful. Getting to know more about BGP.
Okay. Is there any internet exchange in Botswana?
Yes, we have a data center, Bofinet data center. It's a new one. We've been using the one at South Africa because South Africa is the main internet exchange for Africa at Terraco there at South Africa. It's just next door with Botswana.
Yeah. Okay. So Botswana is on the east, if I'm not mistaken.
It's on the south. It's on the south and next to South Africa, next to the South African Ocean. Yeah.
Oh, okay. I see. Yeah. I was in Tanzania many years ago, and then I went to Senegal and then DRC. Never went to Botswana. Maybe in the future.
If you come to Botswana, we are the home of elephants. We are the home of elephants. We are the home of wildlife. I can even see a lion just sitting here in my house.
Okay, let's make sure you're safe.
Yeah. I'll be safe from Corona. Corona is the big problem. So a lot of people. That's why we want to increase the capacity because a lot of clients now that are working from home. What we do is we do layer 2 VPLNs for the office work. So the guys who want to work from home, we give them VPN services.
Yeah, right. Yeah, okay. Well, I think time is up. Admin already informed that we need to end our
more than
session.
30 minutes.
Yeah, it's more than
okay.
60 minutes now. We have to stop because there will be another schedule after this. Okay.
Yes.
So guys,
thank you for your lessons. It's been a great sharing time today. And then maybe we will send to Mikrotik that you are offer. They will consider for your as a sales marketing for their product. And guys, thank you so much for your interest and participation for the webinar today. Maybe we can take a picture. Can you stop sharing first?
Yeah. It's a picture time.
Yeah.
All right.
Yeah,
okay.
The last question.
Thumbs up.
Where is Mr. Tuto? Can you show your face, please? As the finest.
Yeah, sure.
Next time. But my camera is
no problem.
Yeah,
Take
my
your
camera is
time.
good.
Okay, no worries.
We'll talk more, guys. Nice webinar. But I want more. So we need to make that webinar of BGP. Big topic, very big topic.
Yeah. Okay, we'll consider in the future. Right, guys. So please open your camera. I'll take a picture here. 1, 2, 3. Yeah, great. Okay, next. 1, 2, 3. Yeah. Oh, I can see Paul. Oh, you're here. Okay, Jogja is good. Yeah.
Jogja.
Great. Okay, guys, thank you very much again. Hopefully you can get something from this webinar, some enlightenments. And yeah, again, talking about wireless has a consequence that you need to have understanding of the prerequisite topics before we are using the wireless technology. So again, thank you.
And don't forget, please submit your feedback, please.
Oh yeah.
And then you can see our future event. Next week in Tuesday, we have another webinar with the international guest speaker as well.
Oh yeah, next week on Tuesday.
Join our Telegram group and other things. And you can see the YouTube channel. We updated already. So yeah.
Yeah, for the past webinar, we already uploaded on YouTube, and you can have a look there. Right, guys, thank you very much.
Thank you so much for this evening.
Yeah, thank
See
you,
you
admin.
next time.
Yeah, see you next time. Okay, have a nice day. Bye.
Bye.